Hi guys, it's finally our last lecture in Advanced Functions. We're going to go straight into lesson 9.7, Modeling with Functions. Algebraic functions and models are sometimes used to make it easier to solve real-life situations. So take a look at this situation. About 5,000 people live in Sanji's town. One person came back from their March break and then got a virus. A week later, 70 additional people have the virus. And doctors in the town predict that about 8% of the town's residents will eventually get his virus. And that's all we're told. That's all of our given, so we know nothing about what happens in the second week. We don't know how many people are affected, nor the third week. We're asked to select an appropriate function to model the spread of the virus in Sanji's town. First, we can try linear model. In step 1, we have to state our given data. We know at day 0, only one person got infected.
That was a person who went on the trip and got the virus. A week later, 70 additional people got it, so in total we have 71 people who are infected with the virus. We can solve like we solved in related rates, in which we have delta P, which is the number of people who got infected, divided by delta T, which is the time elapsed in days. So that would be 71 minus 1 over 7 minus 0, that would be 10. So in this case, the y-intercept will be 1 and the slope is 10. The final equation would be pt equals to 10 times t plus 1. Predicts that number of people infected by the virus will grow at a constant rate because it is a linear function of 10 people per day. So how long will it take for 8% of the population to get infected? Well, 8% of 500 would be 5,000 would be 400. So we simply plug that into the equation for PT. 400 equals to 10t plus 1. Therefore, t will equal to something close to 40. And the graph will look something like this. At day 0, we have 1 person infected. At day 7, we have 71 people in total. And at around day 40, we have 400 people infected. Keeping in mind that I just drew this graph as a reference and it is not to scale. Okay, we also have the exponential model that we can use. Once again, we have to state our givens first. At day 0, we had one person infected, and a week later, we had 71 people in total infected with the virus. Step 2, we write out our equation. Exponential equation is pt equals to p0 times b to the power of t. The pt would be the total number of people infected, p0 is the initial person, in this case infected, b is a constant in which we'll try to figure out by calculating the givens, and t is the number of days. So we know the initial number of people infected is 1, that's from the given. At day 7, 71% in total got infected. And we solve for b. b equals 1.8385, and that would be the constant for this question. And the exponential model equation is pt equals to p0 times 1.8385 to the power of t. The exponential model predicts slow initial growth followed by a much faster growth. So how long will it take to get 400 people? We solve using logarithm. So we log both sides, and then we can take the t down to the front and divide both sides by log of 1.8385, and t will be 9.84. The graph will look something like this. If we use the exponential model instead of the linear model, you can see that it will take way less time for 400 people to get infected. Well, that it took 40 days in the linear model, but in this case, it only takes around 10 days. Last, we have the logistic model. In step 1, we have to once again state our givens. So at day 0, we had 1 person infected, and a week later, we have 71 people in total. Now we have to try to figure out our equation. Substitute p of 0 equals to 1, and that will give us pt equals to 400 divided by po plus a times b to the power of t. When t is equal to 0, b to the power of 0 will be equal to 1, because anything to the power of 0 is equal to 1. And pt is equal to 1. So that would give us 1 equals to 400 divided 1 plus a. So a is equal to 399. Now we can substitute p of t equals to 71 and see what we get for b. If we solve for that, b equals to 0.5291. A and b are both constants, so the model looks something like this. And this would be the graph. The logistic model predicts slow growth followed by a rapid one and then a slow one again, as a maximum number of people infected near 400. Present a horizontal asymptote at t is equal to 400, and that occurs when t is close to 12. So that's the end of this lecture. I wish you guys best of luck in your exams.